So our final step is to create a flowchart out of our pseudocode. So a flowchart is another way to represent the algorithm, to represent the pseudocode in a visual way. You can use several different tools to create a flowchart. You can even create a flowchart straight from Word. However, I have a program here called Flowgorithm, and it pretty much makes flowcharting a lot easier, and it even allows you to run the program from your flowchart as though it is a real program, even though this is not a real programming language. So it's super helpful in being able to see how your program actually runs and doing error checking and things like that. So the one thing to keep in mind with Flowgorithm, it's a free program, by the way, that you can download. But the one thing to keep in mind is that while pseudocode does not have a specific requirement for syntax or the keywords that you use, Flowgorithm does require you to use certain syntax because of the way that it runs and the fact that it can actually run the code that you put in. But if you put in something wrong, it will give you an error message and it will kind of tell you where you went wrong. So sometimes it's just a little bit of trial and error with this program just to learn the system and figure out what the rules are. But I will give you some pointers through this video as well. So when you create a flowchart, the different shapes represent different parts of your program. So basically you're just going to follow your pseudocode and enter each one of those components as a flowchart symbol. You can see that it always starts with main and end, which again is why I chose those keywords to begin and end my pseudocode. To add a shape, you can simply click on the line between the elements that you want to add the shape, and you can see how the different shapes represent different parts of the program. So we have input output is our parallelogram here. Variables are going to be the rectangle. You have control structures, the if statement, and then you have ones for the 3 different types of loops. So our leading decision loop, our trailing decision loop, and our counted loop. So all of these different shapes line up with the elements that we have in our pseudocode, and they're nicely labeled and color-coded. So when you finish creating the flowchart, it is a very nice visual representation of the program. It's often a lot easier to follow. So the very first things we have in our program are to declare these 2 variables. So we'll go under variables and select declare. To edit what's inside a particular shape, you double click it. Then it pops up and allows you to specify the variable name. So the first one will be high temp, and then the type we can choose from integer, real, string. String is the same as character, or Boolean, which is a true or false value. So for this purpose, just like in our pseudocode, we're going to select integer, and then we click OK, and now that variable is declared. So we'll do the same thing for low temp, integer, and now we can move on to the input. So we'll select the input symbol. Again, you just double click, and all you have to put in here is the actual variable name that you want to prompt the user to input. So we'll do one for high temp and one for low temp. Okay, in order to do the calculation, which first we'll go ahead and declare our average temp variable. To actually perform the calculation and assign that value to average temp, we're going to use the assign shape here, which is under variables. So assign, you can see that it is formatted very similar to how we have our pseudocode. So we start with the variable on this side, and it already has the equal sign in here, so on the right side we just put in our expression or our calculation, which in this case is high temp plus low temp divided by 2. So now that calculation is in there, and it will assign that value to the average temp variable. Finally, we have our output section. So output average temp, that one's pretty straightforward. Select the output symbol, and in this case, we're going to put in the variable average temp. Okay. And then we're going to get a little more complicated as we add our if statement. So you can see I can select the if structure here, and the way it's formatted is you put the condition under if, and then you specify an action for true and you specify an action for false. Or you can specify an action on one side or another. You don't have to put an action on both sides. But I'll go ahead and put my condition in. The very first condition is that average temp is greater than or equal to 80. Okay, now if it's true, then I want my output to be the average temperature today was hot. So under this line of true, I'm going to put an output symbol, and here I can put in quotation marks what I want it to print. Okay. So here it'll output that the average temperature was hot. Now if it's false, in our pseudocode we go back to another if statement, so I will go ahead and select another if statement. So you can see how it formats a nested if. The condition on this one is that average temp is less than or equal to 59. If it's true, then we're going to select another output, and this one will be the average temperature today was cold. And as we see in our pseudocode, we don't do another if statement because there's only one other range that the temperature could fall in. And so under false, we'll just put the output for the average temperature today was moderate. Okay, so it's as simple as that to create the flowchart out of our pseudocode. And once we have it formatted like this in Flowgorithm, we can click this button here, Run, and it will actually run the code. Now in their console, you can see down here it says please enter a value of type integer for high temp. So it does give a sort of prompt of what you're supposed to enter. However, if you were writing a real program, you would need to put in prompts like this, and you can actually do that in Flowgorithm, but to make it more clear what you're asking the user to do. And I'll demonstrate that in just a minute so you can see how that works, and if you want to incorporate it into your programs, then even better. But let's go ahead and test this real quick, and I'll use some of the values that we did for the desk checking. So first of all, I'm going to put in 70 for the high. Now it's asking me to enter the low temp, so I'll put 48. And it returns my average temperature as 59 and says the average temperature today was cold. So that is correct. Now you can see that it just returns the number. It really doesn't say the average temperature was 59. Like, you would have to specify how it presents that, and I'll show you how to do that as well. But this just kind of walks you through the very basic logic of the program. To run it again, you have to click Run, the play button again. Let's try another set. So 91 for the high and 77 for the low. That returns 84 and says the temperature today was hot, and that is correct. And I'll run it one more time, and we'll put in values of 78 and 64, and that returns 71 and says the temperature was moderate. So we can see that the logic of the program is working. Now, let's put in a little bit of extra stuff, just so you can see how it can give the user feedback. So before high temp, we can actually put in an output symbol. And in that symbol, we can simply make the statement, please enter the high temperature for today. Then allow the user to input, and before low temp, we can again put an output statement that says, please enter the low temperature for today. And then under output average temp, we can dress this up a little bit, and we can actually combine a character statement with variables. And this is how you do it in Flowgorithm. And it is similar in some actual programming languages, but the rules do vary just depending on the language. But in Flowgorithm, you can go ahead and put whatever statement. So you might want to preface it with the average temperature today was, and then we put an ampersand, and I'll go ahead and make sure there's a space in between the quotation marks as well. Then our variable, and then I can put another ampersand to put in another character value and put in degrees. So that way they know what format that temperature is in. The average temperature today was, and it'll fill in the number from average temperature degrees. So that will kind of dress it up and allow the program to give the user feedback that explains what it's giving them. Okay, so if we go ahead and run this, now we immediately get a prompt that explains what we're supposed to enter. Please enter the high temperature for today. So I'm going to put in 87. Please enter the low temperature for today. Let's put in 72. Now it says the average temperature today was 79 degrees. The average temperature today was moderate. So now we can see that it gives us prompts that explains what we're supposed to do, and it also explains the output that it gives us. And it looks very seamless because it pulls in that 79, the average temp, as a variable and just basically inserts it into this sentence. So that's kind of how you would add those little prompts so that the program is more interactive and easier to understand for the user. But that's just kind of a quick overview of how to use Flowgorithm, how to create the flowchart. You can use these same type of symbols and actually just draw out the flowchart if you wish, or use the symbols in Word. But I just find that Flowgorithm is an easy way to draw it out and also test it at the same time. So hopefully that gives you a good starting point on how to use this program, how to create a flowchart, and how that can be useful in designing a program and seeing how the logic works. If you want to, you can save this file just as a Flowgorithm file so you can go back in and edit it. You can also print it, and then you can even print as a PDF if you want to save the file that way. So that way you can have a record and print out the picture of your flowchart and everything to go with your code. But that's how you create a flowchart. It's an easy way to represent your algorithm and continue with your testing to make sure that your program logic is correct.